Hello everybody, Ramjet here. Gonna do something a little bit different today. I've been promising lots of people for a long time now that I was going to finish more information on the G25 Shifter and pedals mod that I've been doing many years ago. So many apologies, it's been a pretty wild 4 or more years, and today, while we're in lockdown and the kids are reasonably quiet, I might try and sit down and go through some of this with you. Um, okay, what you can see on the screen today, and I'm going to try and bring this up so I can see my stream at the same time. Okay, what you can see on, let me quiet that, there you go. Okay, I can see what I'm doing now. So what you'll be able to see is on the bottom left corner is my little Arduino test board. Okay, so this is, where's the camera? There you are, just a little breadboard. And the type of Arduino I'm using is a Atmel 32, sorry, 32U4, or a better known as an Arduino Leonardo. But this is the strong board. It's a if you search for this on eBay or something like that, you'll find a strong version of the board. And what's really cool is every single I/O has its own ground pin, VCC pin, and its own signal pin, which means you can adapt, well, anything you want or just develop on this board so much easier than using a standard Pro Micro. It's a little bit more expensive. It's probably about $1 or $2 more expensive than a Pro Micro, but what this saves you in terms of wiring later when you want to put this into a button box, um, more than pays for itself. The additional two headers are for battery backup and external power. So if you are running a say like a Nextion and a whole bunch of LEDs, and you are running into power issues, then you can actually supply additional power through these extra pins. So if you're running a USB lead into your steering wheel, I would go for this board because you have the option to run additional 5 volts coming in through these two headers. Okay, so my YouTube stream is obviously a little bit behind me, so it's very distracting, so I'm going to get rid of that. I might just leave the chat up if anybody joins. I have 234 subscribers now, which is extraordinarily exciting. So what you can see is I'm going to start with a fresh sketch. What you can't see is I have all of my other previous test sketches and things I've done for other people on the SibHub forum. I've done bits of updated code and all of them, and what I want to do today is sort of try and bring together a little single example sketch, and maybe just walk you guys through what it is I've done and how I'm doing it and why I sort of work in this workflow. So first things first, we're going to need to install a joystick library. Okay, so at the moment you'll be able to see on the screen here, I have an Arduino plugged in. And if I activate that screen, okay, you see the pedals are jittering around. So this is actually running a sketch I did for a guy called Stieg on the SimHub Discord channel. This is a combined set of G25 pedals and a Sequential Shifter 2. I believe I've got kids coming up the stairs, so if they start yakking away, you know, that's just sort of unavoidable. So in this shifter, no, Mummy's not. Hang on, I'm going to mute you one sec. All right, I've got my son with me who's going to want to try and play cars at the same time, so apologize. Yeah, what have you got? You got monster trucks? Yeah, you got one monster truck, and how many other monster trucks? One. Just one. It looks to me like you got more than one monster truck. You've got 2 monster trucks. Do you like monster trucks? Yes. Yeah. The wheel's coming off on this one, buddy. What have you been doing? You've been pulling some rad jumps. Is that what you've been doing? There you go. Can Daddy just finish his video? Maybe. Do you want to go put the TV on in your room, maybe? Give me 10 minutes. Maybe it's 30 minutes. No. Ideally a day and a half. Is that okay? No. All right. So you're gonna play on the shifter. All right. So while he's demonstrating the shifter's durability, this is G25 Shifter. Yes, the knob is missing off the top because I had replaced it with this, well, better video shot. There you go. Brum brum. This is a that was the adapter. God, I did this years ago. This adapter, and it's got a, I think a 3/8 bolt in there. Yeah, 3/8 bolt. Thanks for that. All right, and this actually just fit onto the top of here, whereas the bolts go to the front. Slid down, and yeah, look, it worked. It was a little bit heavy because this is a large. This is actually a bicycle. Thanks, man. Oh, not on my head. All right, can you give me 5 minutes? Will?
What?
Can I have 5 minutes?
No.
Go on, a little bit.
Yeah.
All right, I'll tell you what. Go hunting for chocolate eggs.
Egg.
Yeah, go hunting for some in your room. Go have a look for them. All right. That has bought me about 38 seconds. Okay, yeah, so the aluminium foot pegs. This is it's less. It got me less. This is a foot peg off a BMX bike, and I'm not going to be able to do that because that was on pretty tight. That was pretty cheap, and I thought that was really cool for like a handle, you know. You found a bunny?
Yeah.
Oh, that's cool. What else can you find? All right, I have a few more seconds. This is going to be a rough stream, let me tell you. Alrighty, you guys can't eat all that chocolate today. Oops. Yeah, you can't eat all that chocolate today. Alright. Okay, so it's missing the top anyway. But what you can see is first gear works, second gear works. Okay, I have a toilet run. Hang on. I thought he was dancing a little much. So now you can see why it's taken me 4 years to get back to this. Literally, don't get 5 minutes to yourself. Alright, so yeah, so everything works. Reverse works. All of the shifter buttons all work. As you can see, I've got the hat. It's assigned to a hat for those, and all these buttons work as well. So shifter works. The reason the pedals are juddering around at the moment is because they're basically floating inputs. This connector here is for the pedals. And because I'm not actually at this time using the loopback from the pedal, what the Logitech base actually does is it looks, you'll see on the schematic, if you Google the schematic for G25 or G27 pedals, you'll notice there's 2 pins looped back. Hang on, toilet again, 1 sec. Are you finished, buddy? All right. All right, the other one's coming up the stairs too. Right, yes, so the G25 and G27 actually looks for that loopback pin and then enables the reading of the analog axes. And that's what basically allows the, you can unplug them on a Logitech base and it doesn't go crazy and start jittering around. At the moment I'm not using them, so they're just basically floating inputs, which is why you'll see this jitter right here. So I'll leave that up. As soon as I click off it, it'll stop because it's no longer the focus windows. So so what I'm going to do is, God, I hope those kids aren't going to eat all that chocolate. It's going to be crazy. So I'm just going to just start off with some good practice and actually put just a header in here. So tutorial sketch for G20X, whatever model you want to use, G27, G29, I think that sort of thing. Put my name on it, RamjetX, and today's date is the 12th of the 4th, 2020. Okay, so normally I put like a change log in here. I'm going to call this version 0.1. Why not? My basic setup. Okay, so typically, because there's 3 things I want to do. Well, maybe it's 4. we'll wing it. All right. What I tend to do is I'll create new tabs to put all my separate pieces of code into. So if I'm using pedals, I'll have a tab for pedals. So if I'm using a shifter, I'll have a tab for shifter. That way I can separate all of the code into separate tabs, and much easier when you want to go through and change things later to start looking things up. So I'm going to create a new tab. So up here in the top right corner, if you click this little down arrow, for some reason it's not coming up on the stream because it obviously opens a different window. No worries, I'm going to create a new tab, and we'll call this shifter. Yeah, why not shifter? Let's rename that. Can I rename that? Actually, let's save it. We've got to give it we've got to save the name first. Let's save as. You're not going to be able to see this, but it's again on a different window. So I'm going to call this tutorial sketch. You'll see it change on the top. Sketch, spell sketch right. G. I'm just going to say Logitech. RamjetX, why not? Okie doke. So you'll see the name's changed at the top of the title. Actually, you can't see that. Oh, okay. See, this is why I don't do editing. I don't have the time for editing because I don't get 2 minutes to myself. Those kids are very quiet. Where are they? That normally means they've found chocolate and they're hiding. I found you guys under the bed sheets with chocolate, haven't I? I have. Sure enough, I found them hiding under their bed sheets with chocolate. Now it's all over my hands. God, jeez, it's gonna look like they shit the bed. I'll get in trouble again off the missus. Why they had so much chocolate? It's because you gave them so much chocolate. Alright, let's lock that door, hide all that chocolate. Yeah, it's no wonder I don't get to play on my computer very often. Alright, I'm back. Okay, so what are we now, like 12 minutes in, 20 minutes in? I haven't even started writing any code yet. Okay, so we've got the shifter. Let's create a new sketch for some pedals. Can I rename? Yeah, I'm going to rename that. It's G25 Shifter. That's better. That way I know what it's for. Create a new tab. Pedals. Fairly generic at the moment. And I'm going to create another one for buttons. New tab for buttons. Okie doke. So automatically sorts itself out. So, right. So a default sketch, of course, will have nothing in the game controllers. This will be pretty much blank. So the way you populate that first is we're going to include the joystick library. Okay. So I used to use an old joystick library. Hang on, another one wants the toilet. See, I never get 2 minutes to my bloody self. All right. We're gonna include the library sketch. So go to sketches. You can do it this way. I normally just type include, but anyway. Scrolling down and you pick on joystick again. You can't see that. All right. So what I've done is I've gone through the sketch tab at the top, include library, scroll down until I found the word joystick. And what that does is that just puts that here. So do I leave all of that above? No. Let's move all this stuff down. Put it down here. And I like to have my sketch all at the top. Oh my goodness. My wife just got back and all the kids are in trouble now for eating chocolate and hiding in the corner. Right, where were we? Included the joystick. This is literally make a cup of coffee, make a cup of tea. Heck, yeah, grab a couple of beers. You might be in for the long haul with this one. Including the joystick. So what that's going to do is when you include joystick, I think by default it's going to just load up basic set of pedals, basic set of 16 buttons or 32 buttons, and a basic couple of hats. I'm not sure if that's going to... We'll configure that. That's fine. Okay, so what else I'm going to do is I'm going to say I'm going to define. If you haven't used compiler preprocessors before, this is a pretty neat thing. So if you type in define, okay, you can define anything to mean anything. So you could have banana equals 10. All right. So every time you write the word banana, the compiler is going to replace the word banana with the number 10. Okay. So that's what's cool is you can also use ifs. So you can actually exclude whole chunks of code if something isn't defined. Okay. So yeah, I'll leave that in. So we'll call this. I like to start mine with a definition of G25 Shifter. So I like to know that this is actually a definition and not a variable, because sometimes through the code you'll see other people will just use a definition which looks like it's a variable, but it's not. They're using it to define something. Yeah, so they'll do that. So let's set up the joystick first. Okay, I'm going to copy this because I'm lazy from my other sketch, and I'll talk you through what it does. Okay, so this creates, this is a self-instancing joystick, and it's going to create a new joystick, and it's going to use this particular type of report ID. So default report ID, you can actually create report IDs, the HID USB call it protocol, has different report IDs if you want to have multiple devices on the same USB device. So you can have the Arduino be a joypad, a mouse, and a keyboard all at the same time. And when it sends back through the USB protocol, it'll send back a report for where the mouse has changed, what keyboard buttons you press, and what gamepad buttons you press, but it'll have like a header report ID, and it'll say this came from device number 1, this came from device number 2. I think by default this is device number 3 because USB report ID 1 and 2 is reserved for keyboard and mouse, and I think this is number 3. You can change the type of USB joystick device you're going to do. I think the library will show you how to do that. Have I got the library up for that? I don't. That's an entire different video about how the guy actually wrote this library. But what you can see is it comes with a default report ID, a default gamepad device, which is what you see in the you'll see that come up in the game controllers, Arduino, Leonardo, and yeah, everything inside here is default. Okay. Specify the number of buttons you want. You can specify the number of joysticks you want. Hat switches you want, and how many axes. So everything here is an axis. So you've got an X, Y, Z axes, R, X, R, Y, and R, Z. I like to call them the RamjetX, the RamjetY, and the RamjetZ axes, just because. You can have rudder and throttles, accelerate, brake, and steering as well. So you'll see what let's see, I'll show you what I've got. Okay, so this is false, false, false. False, false, true. So you notice in here, there's no XY box. Normally they would come up in an XY box. If you turn both of these to true, so if you set that to true and that to true, no, I'm not going to do that just yet, then you will actually enable the XY box. Everything you see in the Leonardo properties window is basically set up here. Okay, so you can configure it if you want to have it, the axes called accelerator, brake, and steering, or a rudder and a throttle. If you want to set it up that way, it's quite easy to just muck about with this. You can have up to, I think, 128 buttons, but as you can see, the default controller will only ever show you 32. makes debugging a little bit more difficult later. So you start with 32, get a feel for it. Once you know you're really mapping these correctly, then you can expand beyond 32, and you can sort of trust that you're going to get the right input later, because you can't really sort of check it easily. And that's how the joystick's set up. So you could theoretically, this will actually compile. Let me bring this little window up from here. That's better. Everything built okay, so that was nice and easy. I haven't really done anything, but what you can do, periodically try and compile. Probably good practice. That way you know, if you do a quick compile and everything built properly, especially if you're doing this sort of setup, you know you've got things configured correctly. It's a real pain if you get 30 minutes into writing a ton of code, and the last time you did a quick compile to check if everything was fine, and you don't know where your mistake is. You can guarantee you'll have missed one of those, or you'll have put a comma where it should have been a full colon, or you've got yourself too many curly braces, something like that. Okay. Oh, by the way, I'm not going to be doing a how to code in C tutorial. There's thousands of us on the internet to do that. Okay, so defining the joystick's defined. The actual number of buttons are defined. What did I do in my other piece of code? Oh yeah, that's what I did. All right. So no, am I going to do that? No, I'll do that later. Okay. What we'll do is we'll set up some parameters nice and easily. So I'm sticking with the keeping the brake true, keeping the throttle true, and the Z-axis. I don't know why I had a Z-axis. I think I used that for the handbrake at some point, or I used it for the clutch. Anyway, so in my setup, let's do it under pedals. So under pedals, I'm going to create pedal setup. Okay, and then if you just hit that, it gives you that. So what I like to do here is do all of my setup in the appropriate sections here. So I can actually just call this routine, and I can do all of my setup. So I'm just going to paste this in here, and Control T auto indents everything. Also a really good way of finding out if you've got too many curly braces. If I put another curly brace below here, watch what happens. Nothing, allegedly. Weird. Alright, it should have shifted something over, but anyway. While I'm here, I think I'll set up under preferences, I'll also enable code folding. No, it is enabled by default. Okay, code folding gives you this little, there it is, this little plus minus key, so you can actually fold up all of your functions or methods. So if it gets pretty unwieldy, you can actually clean that up. So what I'm doing here is I'm just going to say create a pedal setup. I'm going to do the same thing for my shifter. So I'll just, what did I say my other one? Let's just copy and paste it and change it. Copy, paste, paste. Okay, I'm going to call this G25 Shifter. Shifter setup. And I'll put this, copy that, put this into here, and I'll do the same thing here. This is going to be the buttons. I like having them lowercase at the beginning. Just put that all the same. Like I say, it's not going to be a fast tutorial. You're probably not even going to watch the whole thing, but it gives you an idea as to how I like to structure things. So normally you'll have things in here such like starting the serial. So I'm going to actually just put my serial in here as well. Serial.begin 9600 board. You can make it faster, but in all honesty, If you're using the serial and you're sending serial back, be aware that how does that work? If you don't have a piece of code, if you connect to it with a piece of code like the serial monitor, okay, so if you use the serial monitor up here and then close it, and you're voluntarily sending data back from the Arduino, so you're basically pushing data from the Arduino into the PC. If there's nothing there to acknowledge it, so if you close down the IDE and close down any kind of serial monitoring program, it won't get the acknowledgement that the packet was received or the data was received, and you'll actually get a timeout. And you might see this in your code as if you're making a set of pedals where the pedal intervals would seem to update once every second. It would be like really, really slow. That's more than likely going to be your cause. So if you're using serial data and you're sending data back and there's nothing to receive it, there's a 1 second timeout by default in the, I think the Catalina firmware that's actually on the Pro Micro. So just be careful there. If you are using the serial, sort of make sure you either have the application on the PC and ask for the data rather than sending the data directly to it. Or if you are going to send the data directly to it, put a mechanism in place where you can actually turn off that push data to the PC. That way you can, if you've never connected serial data to it, it's fine, but once you do connect to it, that's going to be a trick for you later. So just a word of advice there. I'll use this for debugging. So let's define let's put a spot for my definitions. So definitions. So this is where I'm going to put all my definitions. So define debug. So I tend to use this if I want to use debugging in the future, and this is going to sort of wrap around here. So I'm basically going to encapsulate everything that I do to send data back into this preprocessor, so I can actually compile with or without all of my serial code. So my preprocessor is going to say if defined debug, then you do all of this, and then end if. I think it is. That's it. That should be right. And Control T just auto indents, which is great. So if this isn't defined, so if I comment that line out, then none of that's going to work. Okay, so that doesn't get included. Because it is defined, the serial.begin is now included when it compiles. So it's a way of, not actually compiling all of the code if you don't want to. So it gives you some options. So I'll start putting some things up in the definitions area and wrapping parts of the code around with these if defs, and that way I can cut bits of code out nice and easily. Okay, so what am I going to start on next? So let's just set up some basic code in the pedals section. So in the pedals, I'm just going to initialize all my axes. Okay, when you use that term there, joystick dot, and then you have whatever the command is, and then brackets what you want to do. That is referring to that bit there. You can call this joystick underscore banana, and the joystick will now be referred to as banana. So if you wanted to call banana dot set break, if you've got brakes on your bananas, that's how you would do it, and that's where that name comes from. You actually set it here. Okay. Let's set up some pins, some button pins. I'm not going to go too far actually with the pedals, because I was going to work on the shifter first, but I might make that another thing later. So I'm going to copy some data that I got from my other one. So in here I'm going to I'll put it in the top here, right above this. I'm going to make some code here that just basically tells me, when I come back to it later, what the pins are going to be. So this I wrote in the Stieg 25 pedals and shifter thing. This is from the G27. I'm going to double check that while I'm here, just to make sure I've got the pinout correct. Pinout G27, G27. I'll pull that out, pop that there. Someone's got a schematic for it online. I never sit here and remember this stuff. It's really no point remembering it. It's all over the internet. Which was easier said than done. There you go, Chris Jansen. He did a pretty decent picture of it. So the G27 pinouts. Huh, I had it like 2 minutes ago. Give me a sec. Shifter pinouts. Shifter pinouts. That'll do. That'll do. All right. So the let's just double check that. Pin 1. Pin 1 is the clock. You can call it S clock, which is normally signal clock, but I'll nickname it shifter clock. Pin 2 is the data input, or as he's referred to it as MISO. The chip select is pin 3, which is the data latch pin. So if you're not fully aware, all of the buttons on the shifter, all of these are actually pulled in from from basically a parallel to serial converter chip. Yeah, all the buttons are basically in parallel, and they get latched into parallel into serial mode, and then clocked all the data out, which is basically the data coming out of there. And each time the clock goes up and down, a 1 or a 0, well, the button conditions are basically clocked into the processor. So that's what that is. That's basically just a parallel in, serial out, or piezo chip. So at the moment I've got the G25 connected. I think I might swap over to a G27. No, I'll leave the G25 on. Okay, so I'm going to take all of this. I'm also going to create another one for the G25. So I like to have this detail in here. So I'll leave that there. I'm going to call this the G25. The G25 pin. So the serial clock goes onto pin 7. Copy goes onto pin 7. Pin 7 is pin 1. So I'm going to cut that. So the VCC is on pin 1. Can I show this at the same time? I don't really want to. It's got all my other bookmarks and stuff on there, so I'll just copy this off the website. Copy. Yeah, it's not pretty, but you'll get an idea. It's just a pinout, and I'll just put that. I'll leave that there for now. Okay. So I think that's the only changes between the G25 and the G27 shifters. They ended up swapping the VCC. Yep, they swapped the VCC on pin 7 with the data, and VCC and data. I'll just double check that because I've got the G25 actually installed at the moment. So pin 1 is indeed VCC, and pin 7, which is 1, 2, 3, 4, 5, 6, 7, must be the yellow wire. Yellow wire indeed goes to, there you go, goes to pin 10 on my code. Oh, so this is the DB pin. So we'll go into setting that up. And pin 10, I think. Pin 10. Where did I set that up? Here it is. Pin 10. Sorry, pin 9. Oh, blimey, that's really hard to read with all those wires in no place. Okay, that's fine. I have a G25 shifter control piece of code here that I am going to copy and paste over into my shifter area. So I'm going to get rid of this. That's not needed anymore. Confirmed all of that's correct. So just going to check G27 is going to be clock on pin 1, data on pin 2, latch on pin 3, shifter X direction, or he calls it pot X on 4, 5 is ground, 6 is ground. Actually, five's not used. I'll take that away. 5 isn't used. Actually, I haven't even got it wired here. Pin 5's not even wired. So I'll just take that out. Oh, redoing this all from scratch again. Shifter Y is just checking. Shifter Y is on pin 8 and pin 9. Pin 9 is actually a loopback pin. And normally you would loop 7 and 9, and here you would loop 1 and 9. Let me check that. Yep, on the G25 you would loop 1 and 9 together. That's actually, you don't actually loop it, sorry. That actually gets looped in the connector here, or probably actually back on the circuit board. This is basically the detect pin. So pin 9 on both devices will basically be VCC looped back to here. So if something's not connected, you'll have VCC on this pin, but this will still be basically nothing. And that's how you detect whether something's connected. So I'm going to leave these here, and I'm going to refer to these when I start building my building the code. So in the shifter setup, pretty sure I can pop this inside here. It's been a while since I've done this. My goodness, it's been ages since I've written code like this. I'm going to define the shifter pins. Copy. Now, if I should be able to do that. I should be able to put that there. If I compile it, will it compile? It does compile. So here's what I'm going to do. I'm going to actually wrap this. Okay, so this is a G25 shifter. And I'm going to define this. If def, I'm going to call it G25. And then I'm going to end if. Now, what I've done here is I've just defined the pins. So on my particular Arduino, my shifter X and Y, okay, is going to be pin 8, A8, A9, which is on the other side of the Pro Micro if you're using one. 5, 6, and 7 is going to be for the data pins, and pin 13 I'm just using for the LED pins. In all honesty, I've never ever seen those work the way Logitech use them. So I've just defined it as pin 13, so you'll basically notice the LED pins will toggle on and off on pin 13 if you have it connected. But yeah, you can make, just even pin 13, it'll be fine. So I'm going to do this again, okay, but this time I'm going to create one for G27. So G27, and what I'm going to be able to do is here, I'm just going to, you can put the same configuration here and just wire these up differently. But if you want a different configuration, say for example you have two shifters, you have a G25 and a G27, and occasionally you want to swap between the two, what you could do is actually change the assignment of all these pins based on the you can set up the variables and modify the variables as you're running a piece of code. So these are just going to be two templates, one for G25, one for G27. They're both identical at the moment, but I'll instead of me rewiring this, I will actually swap them around. So pin 7, pin 7. So can I do that? I can't do that. Can't do that software because I physically have to move the VCC pin. So I'm either setting the code up this time around for one or the other. And if I use an internal pull-up to try and power the entire Arduino, the entire shifter, I think I'm going to get into loading issues, like too many buttons hanging off or too much gear hanging off one I/O pin. Right, I'm just going to leave this defined, but I'm going to only use the G25 one because that's what I've got physically plugged in. No big deal. So here's all the pins I'm going to use, and then I'm going to instance the actual code. So I'm going to copy this over from my other one. So under my G25, I'm going to actually call the instance. Now let me just run through this for you. G25 is the name of my library. I'm going to call it G25. So the G25, should I call it shifter? No, I'll just call it G25. G25. See the choices you get when you write code, like trying to forward plan it. And what that's going to do is going to take shifter pin X or shifter X pin, which is this one here, and it's going to replace A8 in place of this. Now, what this is telling you here is the constructor for the library, and the constructor means what data do you pass into the library so that it knows how to set up the shifter properly. So the shifter needs to know what the X and Y analog axes are going to be. That's what the joystick here defines as being left, right, up and down, and that's what determines your gear. The data input latch and clock pins, that reads all of the buttons on here, but it also reads the button for reverse. So if you've configured this wrong, you might find your X and Y will work fine. You'll get gears 1 through 6, but you won't be able to get reverse because you're probably not reading the data properly for this switch on the bottom, which is linked to all these buttons. Another pro tip there. So I've left I left this in the library because a library originally started off on a Teensy board, and it didn't originally compile on Arduino, and I just didn't want to get back into Teensy. I just found it a real pain in the ass to work with. So I just left this as pin 13, and I left those two LED pieces of code in there. I didn't really go pulling them out, but I haven't ever used it, so it's not a big deal. Okay, so in the setup, did I put anything in the setup for it? Yes, I did. I actually had to call joystick.begin. Okay, so joystick again is the same name we used here, and we're going to call joystick.begin, and that basically is going to start the joystick. So that will end up showing up in here. Okay, this doesn't show unless you call a.begin. Right, moving on. So what have I got done? I got pedals are set. Okay. Buttons. G25. I'm not going to do anything with the brake pedals yet. Okay, let's do that. Right, so going back to the main code, so I've got buttons isn't doing anything yet. I haven't actually set up any buttons, haven't set up any pedals, even though I've told the Arduino library to, the joystick library, just to baseline all of those axes to 0. They'll stay at 0 until I update them as well. So this is basically calling the 3 set functions in each of these. I can now actually start writing some main code. So what I like to do is, before I go too far, just put a comment at the end here, end loop. So when the code starts getting more intricate in the middle here, you might have like a ton of code moving along. Something disconnected, God knows what. I don't know if you guys hear that at home, but I have something that just periodically disconnects and then reconnects, and I have no idea what it is. Okay, so I'm going to get, okay, so the function I have for getting the shifter is on the G25 get shifter. In my shifter, I'm going to actually copy this all over. Yeah, why not? I'm going to copy this all over. So this was just the setup. Now this is what I'm going to call so G25 Shifter. So in my main loop, I like to keep it nice and clean, and then put all the messy stuff in these little tabs in here. Okay, so if you want to disable everything to do with the shifter, you can just comment out that one line, and everything in shifter here just stops working. Okay, so it's a good way of being able to separate your code out. So the first thing I'm going to do, or the only thing I'm going to do at the moment, is get the G25 shifter, and this is going to everything about the shifter is done here. So going into the G25, this is the function that I'm going to call. Okay, it looks pretty full on at the moment, but we'll work our way through it. Kids screaming outside. I have no idea what's happening. Okay, so we're going to set the joystick X and Y. You may notice we didn't actually include joystick X and Y, but for shits and giggles, why not? Let's go back and set the joystick. Oh no, I won't. And the reason I didn't call joystick X and Y, the reason I didn't include it is when you want to assign a button to a game, if you still have the X-Y axes enabled, when you go to select a gear, it will try and actually assign first gear to the X-axis, and you don't want that. So I'm actually going to leave those out. I'm going to leave those. Actually, just delete it. Just delete it. Just delete it. Okay. So you don't have an X and Y axis if you're going to use the G25, because if you do, like I say, the game's going to try and map to the X-Y axis. That's why up here, nope, sorry, in here I have the XY turned off. That way it doesn't show up in this window, and you can't accidentally map it to that. It will accidentally map to this, mind you, but normally when you plug the pedals in, it'll not do that. Let's what I can do though, if I go to pedals, right, okay, yeah. So in pedals, I'm just setting them to 0, and because I'm not updating them anywhere, that jitter won't happen. Fantastic. So I'm going to compile. I had an issue, that's right, I had an extra end if at the end of here because I copied it from my other one. Compile again. Multiple libraries were found. G25 not declared. Did I not declare it properly? Ah, right. Rookie mistake. Gets me every time. Okay. G25 hasn't been declared because in my definitions I haven't actually defined G25. I defined it as... I'm going back on myself here, aren't I? I'm going to call it G25. Define G25. Now, because the G25 has been defined, the preprocessor will actually look at this and go, yep, everything within here can be processed, and G27 hasn't been defined, so everything in here will be ignored. Okay, so now this G25, which G25 Shifter has been called G25, the update function should now work properly. Bastard. Expected constructor, deconstructor, before token. What have I done? What have I done? I'm not sure if I can call that here. I'm gonna cut this out of here. I'm pretty sure this has to be in the main section. This is sometimes a problem where if it's in a method it'll work out here, but if it's not, I'm just going to put it under here, just underneath my definitions. You watch, this will work now. Let's give myself some space, make it nice and clean. Multiple libraries found for joystick.h. Am I missing something? Nope, that matches up. I used joystick, didn't use my old library, which is good. Expected constructor, type or conversion before. You know what I haven't done? I haven't included my G25 library yet, have I? That's what I haven't done. That's one Ramjet. Okay, let's bring in my G25 shifter. Include. Oops, not there. That's why. That's why. You watch, that'll work now. I've got other errors, but I'll work on that. What's the main error? Blimey. You know what to say. When you fix one error, you create a million others. G25 shifter. Creating G25. I'm going to have to pull this all over, aren't I? Let's pull this all over. Cut that. Put that over here. Put that in there, and put that in there. Is that going to compile? What am I doing wrong? This is really embarrassing now. It's amazing how often when you're tired you just stumble through this stuff. Okay, so that's, I don't think that's a game breaker. Expected. Okay, that's going to freak out. No, it's not. That should be fine. That should be okay. $35, $29, $35. That's all right. That should all be all right. Don't understand why that's not working. Let's comment that out for now. Okay, it's going to freak out about everything in here. Now I must have a mistake somewhere else. And it just happens to get to here and then freak out. I have to find J27. Haven't defined that, so none of that's bad. That should be okay. Let's take all this out for now. Now the problem is definitely in this. So G25 shifter. I'm going to call it a G25. Huh. Let me look at my other code, because that one works fine. Include G25 shifter is called. Let's take that out. Let's take that out. That's what it was. I had accidentally, what I'd done there, because normally I call it def 25 shifter, right? I had defined, let me just bring this back up. I had defined, I've never ever encountered this before, but I defined G25 to be a thing. It's just a definition. And then I tried to actually re-instance something else with the same name, and that's why it was actually confusing itself. So if I put all this code back to where it was, this is going to be hard for you guys to track, but that's okay. Okay, so instance my G25. I'm going to redefine my. No, I'm going to take all that out. I'm going to take all that out. That should work. That should work. I'm going to leave those in there, that they're just notes. I'm going to take my... Where did that go? Right. I'm going to grab my my setup of the shifter. I'm going to put that back in here. So I'm not going to try and do all this. I'm just going to make this work for the G25, and then you can basically just swap the pins if you want to. So they're all defined. That's self-instancing, which is great. That is a duplicate. I'll pull that out because I'm doing that over here. Compile. Ah, there you go. There you go. There's a trick for the new players too, isn't it? I mean, ordinarily I wouldn't do it like that, but since I'm trying to make this up as I go along again, made that mistake. All right. So on the G25, we have our definitions. Clean that up. Keep it clean. G25 is all set up. Joystick has started. Getting back to get the G25 shifter, which I had uncommented. Excellent. So when the program runs, it's going to go here. It's going to go to the shifter. It's going to set it up and come back. Run through the rest of the setup. And then when it gets to the loop, it's going to go running this get the G25 shifter. So this inside here, everything the joystick library is going to do is going to get it from out of here. So first thing I do, the library I have adapted / modified, sort of 50-50 really. The G25 has an update function, and I can probably show you that on the library. Notepad++, ta-da! So inside here, I have, okay, so in the G25 Shifter.h, you can see under public, this is all of the different methods that can be called, and just a very quick description. So you got get all buttons, get a single button, get the current gear, get the brake if you put it into like handbrake mode, shifter mode, H shifter or sequential shifter. That's what it actually returns. Is it up a gear or down a gear? Get the handbrake, update. This updates the entire, so it does basically goes and grabs all of the buttons off that parallel to serial converter chip. So that's what refreshes all of the buttons. There's a debug as well. So inside here under print, if I show you down the bottom here, I have a debug somewhere. So a print, so you can actually print all the serial shifter buttons. So if you don't know what's happening, so long as you've got serial enabled, you can get all of the gear, all the debug information out of your shifter and actually print it straight to your serial monitor. So you can actually call that if you need to. Update. See the update here will read the XY values from the shifter, and then goes off and reads all the buttons. And reading all of the buttons, some of this might be familiar to you. Reading the buttons is a get all buttons. Where's read buttons? Read buttons. Read buttons. Where's read buttons? I wrote this thing like 5 years ago, so, and I haven't really touched it since. There you go, read button. So yeah, this just basically sets a clock rate and starts reading the data from the input pin, so the data input pin, and makes a bit value, a bit array, and just clocks that in. Okay, so that's pretty straightforward. Disable that. Come back to where we were. Okay, so refresh all of the buttons, and now we can actually start telling the joystick what we're going to do with the with all the data we pulled back. Okay, so we start with setting the buttons. So now the array of buttons that come back, the first 3 or so buttons aren't actually used, and they're not physical buttons here on the device. Some of them are the reversing button, which has to be read to determine what the reverse gear is going to be. But but you can't actually use it. Well, you could use it to assign something. Well, that's plausible. You could read that button theoretically and actually have another output to put like a reversing light on, a little white LED in the back of your rig. That'd be fun. I might even do that. I'll do that later. I'll get myself distracted. All right. So for the first, I'm gonna have to read this through again. Okay, we're going through and getting the gear. So get gear in the in my library actually returns the button, the gear button. So instead of it reads X and Y and it tells you what gear that should be. Something I should bring it back to in the library on the top in the shifter.h. There's some thresholds here for the x-axis, top and bottom, the y-axis, left and right. Okay, and these values here is based on a 10-bit resolution. So, for example, gears 1 and 2, sorry, the x-axis is the left-right, and the y-axis is up and down. So, if you're below 400, which is to the left-hand side, if you're below 400 on your x-axis, then you are selecting gears 1 and 2. If you're greater than 650, you're selecting gears 5 and 6 or reverse. And depending on the y-axis, which is forward and back, if you are forward, you're picking gear 1, 3, or 5, so all the odds. And if you're below 300 on the x-axis, on the y-axis, you're picking 2, 4, 6, and probably the reverse gear. So if you're having weird glitches, you can play with this in your library. I may end up updating this, so it's something you could probably update, but it's one of those things where you can either hard code it and muck about with it later, or if it's right on the threshold, or you could actually make it something you could send. You could do an auto calibration, but in order for that to stick, you're now then playing with the EEPROM, and really you probably don't want to be playing with that. It's not an issue, it's just going to start getting complex and stuff like that. So I work with the EEPROM for the pedals because I do a lot more manipulation of the pedals, but I just wanted to just sort of plug in and go. These are the values I use, and I have no issues, but then again my potentiometers are nice and clean. If you have some weird strange glitching, you might be able to filter it out here. If you can't filter it out and find a nice sweet spot here, then you are going to have to probably clean your potentiometers on your shifter handle. But anyway, that's if you want to tune what gear does what, and if you select first gear and you give it a bit of a wiggle and you find yourself skipping between first and third, then you can tune these thresholds a little bit. If you're in the middle and you've got a little bit of play in that stick, well, again, you might accidentally trigger into the left or the right hand side. So you might accidentally find yourself in gears 1 and 2 from 3, or in gears 5 and gear 1 or gear 5 from gear 3. So you can play with those settings. Yeah, just up them a little bit, down them a little bit. They'll be fine. And you can actually use the serial, the print function. So if you're finding yourself having some weird glitches, you can use G25.print, and it will print these values for you, so you can see it on the serial screen and go, yeah, 400. Best make that 420, say, just to make sure that it's not clipping into gear 3, that sort of thing. Okay, so I'll leave that for you guys to play with. Oh my goodness, my wife is amazing. She does so well handling these kids while I'm doing this stuff. All right. In the background, they're crying because somebody stole someone's chocolate. Yeah. All right. So here's what I'm going to do here. We went through all of the gears. Okay. All right. So what I do is I go through this there's how many gears is that? There's 7 gears. 1, 2, 3, 4, 5, 6, 7 gears. Starting at gear number 1. If the gear is number 1, okay, so what comes back is either going to give you a gear through 1 to 7. You're going to get a number 1 to 7. If no gear is selected, it's in neutral, you're going to get 0. At which point none of this will come true and everything will just be set to 0. Okay. joystick set button, just for reference, under game controllers, button 1 is referred to as actually button 0. So if you're going to do a joystick set button, you're going to want to actually refer to button 0. So what I do is, I know the gear we're comparing to gear 1, but if 1 is the gear that you have selected, so you've got gear 1 here, you'll see button 1, but what it does is it actually sets button 1 minus 1, which is button 0, and we're going to send a 1 to button 0, which is, funnily enough, button 1. So in the library, button 0 was the first button, because 0 is the first position of the index, and but Windows actually shows you that as button 1 because, well, button 0 doesn't exist. Okay, so we'll moving on. So what it'll do is it'll go through, it'll check, is it gear number 1? No. Gear number 2? No. Gear number 3? No. Gear number 4? Yes. If it's gear number 4, yes, then we are going to set gear number 4 minus 1, which is button number 3. So because by the time you get to 4, that's 5. 5 minus 1 is 4. And if you look here, that's button 4. And we're going to set it to 1. What happens then is, of course, every other button, if it's not that, it will also clear the other button at the same time. So you can't have multiple gears selected. It's either going to be one of these 7 loops is going to be on, the other one's going to be off, or they're all going to be off. Okay, so that's how that works. The black buttons and the red buttons. So the bit stream that comes in from that serial chip, that parallel in serial out chip, I forget, it's either a HN165 or 159, something like that. The bit stream button 4 to button 12, the first there you go. The first 4 buttons weren't used; they were used for other options in the PCB. So we're going to set the button I. We're going to start at button 4, which then we're going to add 4 to it. So we start at button 8, which is the next clear button after that. Okay, so I'm going through the bit stream. I'm getting the bit stream, and I'm going to set the condition of that bit stream. So I actually get the button value, and it's either going to be on or it's going to be off. So that's going to be basically 1 or 0 when it gets that button. And I'm stepping through the index of that and adding 4 to it just to offset this. Look, I could have written this better, but heck, this works. So you should be able to, when I finish this, I'll post it, I don't know, somewhere, and I'll let you know at the end of the video, and you should be able to just copy and paste this straight in, or just run the sketch and it'll just work. The only thing you'll have to do is change whatever pins you want to use here, but I recommend just using the same ones. Okay, the hat switch. The hat switch was a little bit different. It went from bits 12 to 12 to 15. Is that 12, 13, 14, 15? That's 4 bits. That's right. I'm refreshing myself as I go. So we get the hat value, and we're going to shift a 1 logically into that position. So shifting a bit by index minus 11. I can't remember why it was 11. I think, oh, that's right. It's because you start at 12. So 1, 2, 3, 4 shifts into bit positions here. Okay, so when you shifted that value in, it actually equivalated to being a that gives you a switch case. Okay, so when you shift a 1 into a specific bit value, so it's 2 to the power of 0, 2 to the power of 1, 2 to the power of 2, 2 to the power of 3. So you're going to get 2, 4, 6, 8. Oh yeah, 2, 8, 2, 4. Wonder why I did it. I did it like that because 90, 180, 270, 360. So the hat switch, when you're playing with the joystick library, the hat switch looks at a particular rotation. So 90 degrees, 45 degrees would be sort of up and to the right, I think, from memory. But I was only using up, down, left, and right. Let me just check that up. Yeah. So I didn't actually have in the library or in this piece of code here. I wasn't actually using the angles. Yeah, it's just either right, up, down, left, or right. I didn't use the midpoint angles, so the northeast sort of thing. Northeast, or that's that got too complicated when I was trying to use this in games, and it was doing some weird shit. So I just left that as up, down, left, and right, or north, south, east, and west. So that's what I've done. In the hat value, I just added the hat value and I shifted which one of these buttons here were, and I just shifted it into the appropriate bit position, which equivalated these values, which then I just send into hat switch number 1, or hat switch 0, which is the first hat switch. I've only got one hat switch here, and just set that up, down, left, or right, and full. And if you want to clear the joystick, you actually set it. If it's not up or down or left or right, default it to -1. You can also put the word joystick hat switch release in here, but I just made it neg1. So if it's not up or down or east or west, then default is not at all, and that's how you get this to clear. Okay, I think I've got a dicky button here. Yeah, I think my up and down buttons are just, that needs cleaning by the looks of it. Okay, and that is literally how that works. So if I compile that, that should be the entire shifter working now. So we get our update, so we've got a fresh new batch of buttons to work from. We do the gears first, so let's just, I'm gonna clean this up. Set the gear position. Okay. And gears. Populate the black buttons. Black and red buttons. That's right, the black and red buttons is 8 buttons, so 4 to 12. There's 8 buttons because there's 4 buttons for the black and 4 buttons for the red. They just happen to be in that bit string at in the same sort of period, and that's why that's nice and easy. It's a simple for loop. So end black and red buttons. I just like to keep this nice and easy to read so that other people don't like freak out when you first see it. And this end G25 shifter. So you can see if you can actually, if you click here, you see if you click here, you get this little. Oh, you don't see it on the screen. It tells you it's the end of. It automatically puts this little box around the one it matches. That's a good way of knowing if you've actually got enough, because if you get rid of it and you click on here, it doesn't light up properly. It shows you the other matching pairs here. That's why you need to do that and just make sure that matches with the end of that. That way you know when you minimize the function, the whole thing captures properly. Little trick there. Alright, so all I've done is set up the shifter. So I'm going to actually program this. So tools, already configured. I'm going to program it. You watch the Arduino Leonardo freak out, stop doing its thing. So hit go, compiling, uploading, lights are happening. Okay, so that flashed. And you notice the Z-axis and brake and throttle are no longer flashing around. That is because I haven't done anything with them. So when we set them in the setup here to be 0, I've done nothing else with them. It's this little bit of code here that actually sets what happens in the screen here, in the joystick screen. Whatever happens on the physical ports, completely irrelevant to what you see on the PC. So you can actually kind of decouple what you're doing with all the axes and tell the PC something different. So you can actually effectively spoof your axis inputs. So the G25, let's check if that's working. So first gear, that's working. Second gear is working. Third, fourth, fifth, and sixth gear is working. Reverse gear is working, and all of these buttons are working. Excellent, they're all working. Oh, sequential gear. Now, sequential gear I have still got working in the that's actually in the library. So what did I put in here? Let me link to Go back to Notepad. So the sequential gear, if you push this into sequential mode, and I'll click back on here, it's button 1 and button 2. Now I was going to change that so that you could actually map them as something different. And the reason, so the sequential shifts are still. So this is the code here for the threshold for the sequential shifts, and sequential shifter, get sequential shifter. So under sequential shifter in the library, I did end up overriding it because I got lazy there, I think, at one point. Okay, so the gear, it returns the gear. So under get gear, get head shifter. Yeah, here it is. Where did I put it? Is it under here? Under get gear. So because I only have a call get gear, I don't actually change. That's right. I don't actually change between sequential and shifter mode. The library handles that. Where's get gear? Get gear. Read all buttons. Get brake. Get current gear. Here we go. So it looks for the button. That's right. Okay, so this button here, this DI mode, that was the actual bit from the button that you don't get read, or you don't have on this display. When you select sequential and serial mode, it's either going to be on or it's going to be off. And inside the library, I actually automatically toggle between getting the H shifter and getting the sequential shifter. So if this is turned to sequential mode, it actually fires off a different method that it returns. The same get gear command still comes back with a gear, but it's either going to tell you gear 1 or gear 2 for sequential, or gear 1 through 7 or 0 for the H shifter. So when this knob is set to that position, obviously the button's pressed, and it goes off and gets sequential shifter. Sequential shifter. God, it was years ago since I did this. And I think I added this because originally he used to have on the TC version of it, he was doing shift up and shift down, and I just wanted to be able to turn the thing and have it tell me a gear 1 or gear 2, and I just basically assign that button as being sequential up and down. Some games allows you to double set that, so gear 1 can still be gear 1, but button 1 can be up gear and down a gear. So if you want to change it, you can actually change that, but yeah, I would probably just leave it there for now. I might work on that later. I was going to make that, say, button 9 and 10 or 8 and 9 or something like that. That way you make sure you are pushing different up and down buttons for the sequential. And I'll have a play with that later. But for now, that's just sort of how it is. I'm not going to change that just yet, because then I have to change all of this. Yeah, I would. I'd have to push all of these out. I can make this cleaner too. Yeah, that's fine. Yeah, that's fine. Okay, so the shifter's all working. The shifter's all working. What else can I do? I could do pedals. Does anyone want to do pedals? Actually, I don't even know if anyone's watching. I'll do the pedals. Why not? Okay, so I'm just going to pull out of my other bit of code. Let me just have a quick look at this. Let's create a new one. And pedal setup. Void get pedals. So inside here, we're just going to start assigning some pedals and get pedals. That way I know that's the end of my piece of code. So in my pedals, what have I got my other code? Let's see if I can copy this over. Oh, I've assigned a brake, clutch, and a throttle pin. So let's do the pin setup. Okay, let's do that. So normally in setup you will set up a your buttons. So let's do the definitions. Copy. I'm going to copy that from my other one because I'm sick of typing. Under definitions. Okay, so I'm just going to define my buttons in here for my three pedals. So A0, A1, and A2, and a brake adjust pin, which is actually pretty handy. We'll get into that later. So is that pin 2, 3, and 4? Oh no, this was what that's the. Oh, it is, yeah, pin 2, 3, and 4. So that's the DB9 pin 2, 3, and 4. So they're the pins that you pull off this connector here. That's for plugging the pedals into. So pin 2 can go to A0, pin 3 can go to pin 3 of here can go to A1, and so on. And I'm using a separate potentiometer on A3 that I use for my brake adjustments. So that's the pins defined. Okay, because what I like to just have to change this once up here. And I'm going to copy over my setup code because there's a bit of it and I don't want to waste all of your time by rewriting this stuff. So I'll walk through it with you. So in the pin mode setups, we're going to set up each of these pins. So again, where the word throttle pin appears, it's going to be replaced in the compiler with A0 and so on and so forth. So this all makes sense. We're just using an input. You can define something with an input underscore pull-up, and that would enable a pull-up resistor. Reserve those for buttons. Don't use those for potentiometers. If you're going to use a potentiometer, wire one side of the pot to VCC, the other side to ground, and the swiper in the middle is what comes to this input pin here. So if you're a complete electronic noob, then maybe go off Google. But typically you'll find a potentiometer. Which, do I have one handy? I don't. I'll tell you what. Let me go get one. Thankfully, I'm on a wireless mic, so I can still talk to you on the way. Potentiometers. Surely I've got some handy in my electronics workshop. Digging through. I do have one. It's got to be up here, underneath the Nerf gun. Nope. Potentiometers. I got crap everywhere. If you're like me, you'll have this kind of shit laying everywhere too. Nope, that's an LED. I'll get one out of. Nah, bugger it. You can figure it out. I don't want to go pulling all my drawers out. So potentiometer's got 3 pins. Top one and the bottom one are either side of the 10K pot, and the middle one slides up and down the middle of the pot. So use the middle pin. Okay. What am I doing here now? So pin modes, we're going to set them all into inputs. You have to do that, otherwise the analog function doesn't work if they're set to outputs. You got to be very careful if you're setting them to outputs. You can either drive the pin high by mistake and accidentally short that pin through a potentiometer. So don't set anything you're using as a analog input. Don't accidentally set these to outputs, because you can actually supply current from inside the chip to the pin, and if you've got your pot all the way to the bottom, you're effectively short-circuiting the the output pin, and is that how that works? I can't remember if it automatically enables the pull-up resistor. Either way, you have potential to damage it if you set it to the wrong mode and use it in the wrong way. So anyway, set your analog pins to input, and you'll be fine. You'll be fine. Okay, so in the pedals. Now this gets a little bit tricky in the pedal area because, and again, I'm going to copy all this stuff in. I'm going to copy all this stuff in here, and I'll walk you through it. Okay, so in the main code, we're now going to call. You see, I do a lot of copy and pasting. I do a lot of that. I'm going to call my get pedals routine, and I'm going to call it in the main loop. Oops, pop that there. Okay, copy, paste. But the pedals, everything about the pedals is done here. Okay, so nice and clean. I can see now I can disable my pedals if I get sick of my pedals. I can use if statements, I can use conditionals, I can use a little toggle switch if I had to. So if I had like a toggle switch, I could use an if statement on a digital I/O pin and turn my pedals off or something like that. So you can see how this gets easier to work with, even though it looks a little complex up front. So in the pedals section here, we've got the brake pedal, the clutch pedal, and the throttle pedal. I'm just going to brake, clutch, and throttle. Okay. Now, I've got a couple of things going on here. So I'm gonna come back to the brake. Let's work on the clutch. The clutch is basically just an analog read of the clutch pin, and the clutch pin was pin 1. For some reason, why would I have done that in pin 1? I think that's what Stig had his wired up, and I left it this way because the code was compatible with him. Doesn't really matter. You can swap these if you want, but yeah. Anyway, A1 is what I'm using here. So it reads that, and what it does is we're mapping. That's right. He wired it up back to front. Okay. Has anyone ever seen the map function for Arduino? Let me get some detail on that. There's some good shit here. So I'm just going to Google Arduino map function. Okay. And I'll get the map reference from the website. And what it does is it takes. Here we go. Here's the syntax. Copy. Okay, so this is what the map function does. I'm going to just clear this up. What map does is it takes whatever value you've got and it ranges from low to high and it rescales it to a new value range. So say for example you had this as 254, so you had an 8-bit pedal. Okay, then you could remap it to a 10-bit output, or vice versa. You could take a 1023 and this is supposed to be, that would normally be 0 and that would be 123. So you could take a 10-bit and scale this down to 0 and 254, and that would actually be an 8-bit. So you can actually rescale a value to a different range. Do you know what I mean? So if clutch was some value between that one and that one, well, I could put 1 million in here and you would have a scale between 0 and 1 million. Now, a cool trick is if you want to actually invert an axis, okay, so normally this would be like 0 to 255, this would be 0 to 1024, okay, so I'll show you how this normally looks. 254, 0 to 1023, okay. What this would do is take anything in the word value or anything in the variable called value, scale it between that and that, which is some number you've got between those values, and it would proportionately scale it to somewhere between 0 and 1023, okay, which is 10 bits. So you can just swap scales on the fly, which is really, really handy to do. If, however, your pedal is reading back to front, and for some reason you've wired your VCC and your ground back to front, and suddenly when you push the pedal, the thing's going down when it should be going up. What you can do is actually just swap the to and from range. So these two here is to the low and to the high. If you swap that to a high value and that to a low value, like I have here, that will actually invert what the scaling is, and it'll take this and it'll literally invert the output, which is kind of handy to know if you don't want to go rewiring anything. Okay, so I just swapped the last two values and it'll remap inverted. That's what it says here, remap inverted, which is great. So that's what the map function does. I would also probably look at using the constrain as well. Okay, so constrain is another function. This was very easy for Steeg to use. I'll use constrain on the outside of this, and constrain is actually also another really good one. Constrain. I'll get the so here's the Arduino reference for that. It's constrain. Just Google constrain, and the syntax is copy. I'm going to put the syntax in here as well. Constrain will take value x, that was the same as the word value in the other one, and it will make sure it's going to stay between 0 and 1023. And what that does is it takes a value here, and if for some reason on a very rare edge case you have a value in here which slightly overflows here, what it'll do is map proportionately, but occasionally you might get a roll over or roll up or round up into 1024, and 1024 of course flips back around to 0, doesn't it? Because that's the scale you're supposed to be going to, and it'll flip back, and you'll get some, at the very edge cases, you might get some weird glitching on your pedals. So I would very much consider using, and I might even just do that here. So let's use this. Clutch, copy, clutch. Okay, so that goes there like that. Okay, so this is probably not a bad idea to do. Okay, what it'll do is this one will remap. At the moment it's inverting because that's just how the pedals are. If yours are back to front, just swap the 0 and a 1 or 2, 3. That'll sort of remap it back to normal. And then you can constrain it, because if the output of all of this gets mapped to a new scale and for some reason it's 1024, then clutch is going to hold 1024, which is an overflow, and you can't have a 10-bit overflow because it'll loop back to 0 and it'll go from flat out clutch to no clutch and back and forth. And worse still, if it was on your throttle or your brake, you might find yourself suddenly going for full brakes and it rolls back to 0 brake. Whoops, that'd be bad. So you can do this in one really long string, or you can do it in increments. Not really gonna kill you. And I'm gonna do the same for the throttle. So I'm just gonna change the throttle here and just throttle. There we go. So I'm gonna also constrain the throttle. Again, same thing with the clutch and the throttle. They're basically just pedals. Okay. So read the pin, rescale it if you have to, or in this case I wanted to invert it. If it's fine, it's probably not, if you're reading 10 bits, you probably don't need this. Recommended that you constrain it just to make sure that you don't have any weird glitching overflows, and then set the Z-axis, which in the brake pedal, in the Arduino properties, I'm using as the Z-axis here. So I'm just using the Z-axis as a clutch. In the throttle, same thing, read the throttle pin, because I was inverting it for Steeg's wiring configuration. Again, swap it if you want them back. Constrain it, set the throttle, and then use that value there in here to set the throttle. So that'll then update. Now the brake is where it gets a little bit tricky, because what I'm doing is I'm reading the brake pedal. Okay, so I'm reading the brake pedal, which is the brake pin, and the brake pin is A2. but I'm also reading the brake offset. Okay, so the brake offset or the brake adjust pin is a 3. So I have another potentiometer that I have somewhere on my rig. It's like a little dial. You just turn the dial, and I'm using this pin to offset my brake pedal. Now this is great if you're not using a load cell and you're just using a standard brake pedal, because what that does is you use one potentiometer to reduce the value of another potentiometer. So you can use this pot, the brake adjust pot, to limit your maximum range or brake pressure that you're applying to the brake pedal. Now this, when you dial this back, the brake will be adjusted. So what we'll do is we'll get the first off, we get the brake adjust value, okay, and we read the analog pin, okay, and what I do is I divide it by 2. The reason I divide it by 2 is because I'm gonna take the normal brake and I'm going to subtract the offset brake from it. And if I divide it by 2, well, I can only ever subtract half of the full range of the brake pedal, because potentially I could wind my brake pressure so far down that effectively I have no brakes at all. And you don't really want that. You want really half your braking range or better, you know. So I just use this divide by 2. So I'm going to get basically value out of this thing from 0 to 512, which is half of 1024, right? So read the brake pin, and here we're going to map. We do the maps just like we did down here. So we're going to map the brake from 0 to 123, and then here's what see what I've done here. I've taken my maximum range and I've subtracted my brake offset. My brake offset is going to be anything from 0 to 512. So this is going to be 1023, and which is the upper threshold of braking that is allowed to range to, and I'm going to reduce that down to about half. If I set this all the way to half level, which is 512, I'm basically going to subtract half of that. So I'm going to have a range of brake pedal between 0 and half of my full range. This is dynamic because as I turn this potentiometer here, this value changes, and that's how I get a brake adjustment. So I get my final brake adjustment, and that's why I'm constraining it to make sure that I don't accidentally overflow it here, because I am manipulating the values. I do have potentially the ability to go above and below 0 and maximum value if I stuff this up. So this is basically a little sanity check before I send it to the brake pedal. And again, joystick, don't send brake. All of that becomes a final value. You can actually do constrain within the set function. You see that? I'm doing, whereas up here I did it separately. Yeah, you can actually do it in here if you want to make it cleaner. Or you could just drag all that up, push it up there, and put brake adjusted in here. And that's how the pedals work. So that is brake, clutch, and throttle. I've got a brake adjustment pin happening here. Again, I don't have any of that plugged into this at the moment. So when I upload this, let me compile it. Yep, and what are you going to freak out about now? Right. Brake offset was not declared. That's because I haven't copied over my variables. I still have a nasty habit. Oh, you know what? I don't have to define that. I can actually just define that here. I can define that here if I wanted to as well. In fact, I could do that with all of them. So normally I will manually define these as global variables, and so I don't have to put int in front of them, but these variables only exist inside here now, inside this routine, because we actually instance it at the time we need it, and then basically it just disappears once you get out of the routine finishes. So that will, and that one as well, of course. Yep, that compiles there now. If you're going to use separate variables and you don't want to define them within here, where did I put it on my other one? Normally up near the top. That's normally where I put them. So the difference between creating a variable is you actually have to tell it what type of data type it's going to be. What we've done here looks like a variable, but it's not. It's basically defined the word throttle pin to equate to A0. It's just a replacement of a term. This one actually defines a variable, and by putting an integer in front of this, I'm creating a variable that then reserves a piece of memory. Up here, this doesn't reserve a piece of memory. This basically replaces any. It's really literally like the find and replace command in Word. Find throttle pin, replace it with A0. That's literally what doing a definition like that does. Variables. There it is. So if you weren't going to do that, if you're just going to use this like so you weren't going to instance each one. Yeah, that looks right. You can just create the new variables up here. So I've got create an integer. I'm going to create a throttle, a brake, a clutch, a brake offset, and a brake adjusted. These are now global variables that I can refer to at any time through the whole thing. From memory, this will compile because it's outside of any function. That's right. So you can define global variables. If you're going to use them everywhere, then it's probably not a bad thing to do. If it's just a very temporary thing, you could define them inside of your method, and then they basically get discarded once you've exited the method. Where people tend to run into troubles is if they're running this kind of thing in the main loop, and they use temporary values in a function that they can't access from the main loop. So that's probably, probably not a bad idea. If you in Arduino, it's fine. You're not making safety critical systems with this, and if you are, there's better ways to program this than the way I do. So throttle, brake, and clutch, these are global variables. Creating some global variables for these values, and as you can see, all of this is now confined within this whole tab here. I'm pointing to the screen, but you can't see me pointing to the screen because you can see my elbows. That's why. So shifter's done, pedal's done, extra buttons. Well, we could work on some buttons, but really that's just literally doing a digital read, very similar to what we did here. I could wire up a button. We could do that. So this is compiling just fine. If I upload this now, doodaloot, gives me an error because my the controller was unplugged and replugged in when it was programmed. So just there you go. Now, as you can see, the pedals are shifting about. Okay, so I'm just going to keep this selected, but you can see in the code. So I'll leave this piece of code here. I'll highlight that for you. Now, under the brake, on line 27, you'll see that's where the brake is updated. Now, if I put my fingers on some of these pins, I can send them crazy with some static. Look at that. Going crazy. And they settle down when I don't touch them. So floating inputs, by the way, if they're not pulled up or pulled down, will just sit there and act like antennas. And because this long piece of wire is effectively an antenna, any EMI from any other device is just going to, like a radio capacitive effect, it's just going to go up and down and up and down. That's why you see those values skidding about like that. Okay, so I could theoretically now plug it in a potentiometer to my A3 pin, which I'll do. I'll go get a potentiometer. I've got a sliding pot, but it gives you a general idea of what's going on. Because the sliding pot's easy to get hold of because it's sitting on the top of my desk. Actually, these sliding pots are really nice. Are the red ones with the yellow handles on them. You'll find them on eBay and AliExpress, but I'll show you when I get back to my desk. Alright, one of these things. You've seen these before? So there are 3 wires on it. There's VCC, ground, and what's called OTA or output A, and there's output B, which is the inverse of output A. So let's make sure I connect this properly. Ground is black on this one. White is VCC. put that there, and I'm going to put this onto pin. Let's put it on the throttle. Let's put it on the throttle. What's pin? Throttle is the first pin, isn't it? So let's bypass that. I'm going to put this on the throttle. I know you can't see my fingers, but that's fine. So I'm just going to basically bypass the throttle pin from the DB9 connector, and what you should be able to see now is there's that throttle. I've got it upside down. Here we go. There's the throttle working. So 0, full throttle, and there you go. It's working. It's 10 bits. That's right. It's back to front because okay. I'll show you how this works. So down is full, up is off. Okay. I'll go back to here, and I'm going to change that. I'm going to change that mapping. 1023. I'll just demonstrate how this map works. So if I just reprogram this now, doodaloom, doodaloom. There you go. So now down is off and up is on. See that? See how the map works? It's now back to front. So if you get your wiring wrong and you do your code and you're like, oh, I don't want to wire that again, here's a neat little trick. You can actually just remap that inverse. No physical wiring changes. It just maps inverse. So so what I'll do, I'm going to set these all. If I'm going to post this, then I'm going to leave it all default. No, I won't. I'll put them back. And the reason being is I'll work on this offline just to make sure, because I'm going to have to move this brake offset. I'm going to have to move all of this to here. I think that all works fine actually if I just swap those two, but I'll double check off camera anyway. So anyway, that's how to make one of these things. In each of these tabs, here's the G25 pinout, here's the G27 pinout. If I swap these pins around, I can actually plug in my G27 shifter and show you that. Should I do that? Why not? Because I'm going to have to physically remap these two pins here. Yeah, alright, let's see if that works for shits and giggles. So I'll unplug that. I'll take this off. Oh. So I'm just using this is my GT Ultimate V2 chassis rig. And these, if you can, I don't know, can you see these? These are the little end caps. You can get these on Thingiverse. These are makes these arms nice and tight because they're quite sloppy with the little bungs that are on them. So when I pop these on here, and I've got a little mounting. Here's the mounting kit for it. When this slides on here, it goes on nice and tight. You'll see it's nice and flush, and that is completely zero gap there. And just a little quick nip on. You don't have to put a lot of pressure on it. That is literally rock solid. Doesn't even move. Way better than what they come out of the factory stock. So if I'm going to turn this into a G27 shifter, what do I need to swap? I need to swap pin 7 for VCC. Pin 7, which is, I'm going to take that throttle back off. Put that back to normal. By the way, make yourself one of these. They're like a breadboard and screw an Arduino to it, so it's so much easier to do development stuff. So pin 7. Pin 7 went to, what have we got? Pin 1 goes to pin 7. Pin 7 goes to pin 1. Okay. So 1 and 7 swap, is that right? Looking at the screen, pin 1 and 7 swap. Looks about right. It's not like you can stuff it up. So that goes, so pin 1 goes to pin 9 now, and pin 9 goes to pin 1, and theoretically that should now work as a G27 shifter. Let's plug this in. Oh, blimey. This is either going to be good or bad, isn't it? You see, because it's unplugged, it's freaking out. There you go. Let me plug that in. There you go. Is that right? That's not right. It's not reading the buttons. It's not reading the buttons. Let me unplug that. Put that back where it was. Pin 9. Pin 1. I'm going to have to check them. Pin 1 goes to clock. Where's that pin out again? And yep, this literally is how much time it takes to do this stuff when you're sort of trying to research what's going on at the same time. Well, it reckons on this web page that that's the only difference between a G27 and a G25 shifter is pin 7 and pin 1 are swapped. Which makes sense because they're both going to be high or low, and you can swap them comfortably without knowing that you're not going to break anything. So pin 7. Hang on. What's pin 7? So that's 9, 8, 7. 7 is yellow, definitely yellow. I swapped it at the wrong end. I think that's what I've done. Because I haven't changed it at this end. That's what I've done. I swapped it at the wrong end. I've got to change it at this end. Okay, let's see. How's that going to work? Huh. I'll look into that. I don't know why that's not working. I reckon that pinout's got to be different. You can't just swap those two pins. I don't want to take it apart to verify it. Surely someone's got some good data on the internet. Find a better website. G27 Shifter pinout. G27 Shifter pinout. You know what I hate? I hate when people do a pinout and refer to the wire color. Wire coloring is not an official pinout, because when the manufacturer can't get that particular cable anymore and decides to use a different one, you can guarantee the color layout will probably be different, and you can never rely on that on being the a pinout. So when someone posts something online and goes, "Oh, this is the pinout, refer to wire 11 and color purple," it's just, that's not how it works. At some point in the product lifetime, it's going to change and stuff everyone up. He reckons. Okay, so Chris Jansen on GitHub reckons there's no difference. I'll be damned. I'll be damned. There you go. There has to be a difference because my gears are working. Gears are working, but I can't get reverse, if you remember. And none of the buttons are working. So there's got to be a difference in the serial data. There's got to be a difference here. So these one of these three things, if not all of these three things, are different. I can't understand why he can write one pinout and assume it works for both. So in his, he defines his pins in shifter H. What does he call it? I'll tell you what I'll do. I will share G27 Shifter.h. The inputs used by the project are defined as G27 Shifter.h. Let's have a look in this Shifter.h. So he's using that's not super clear how he's using that. I can't see two separate sets of pinouts for the G25 and the G27. So I wonder where he's defining that. Surely he's not doing it under his descriptors.h. No. Alright, well I'll look into this. I might come back with this. I've got to find out what these pins are again. It's been a very long time since I've used a G27 shifter. Yeah, okay. Again, I've found another drawing shows two different things. Where they swap this pin 7 and pin 1, but they also swap pin 5 with something as well. Actually, it's referring to wire red as pin 5 on the G25, and it's wire white on the G27. And the G25 doesn't have a white wire, so how can that be a valid pinout? I don't know. People, mate. People. I'm going to add some background music. Does anyone want any background music? Is anybody there? Actually, let me check. It'll get annoying. Oh, there's one person watching. Is it me? Could be me. I'm watching myself. That suddenly says 2 people are watching. Well, that's exciting news. Fair enough. No one's there. Excellent. Excellent. All on my own. Shifter input. That's for G25. Show me G27s. No, that's for a different plug. Oh, bugger. You know what? I will find this out and I'll get back to you. There must be a decent reference for that. My G25 works just fine. I've got to find out what they convert those to, and the resource I've found online is not working. Well, it's wrong. G27 shifter pinout. I bet you this is the same. Yeah, it's the same image. I'll figure that out offline. I think I've done enough today. What I'll do is I will make this sketch sort of available. Probably I'll probably do it on I'll add a link to the file in this video probably after lunch now, but I do want to get the G27 working as well. But I'll come back to I'll post another quick video up with the G27 working, and that might be this afternoon after the kids have had their nap and that sort of thing. So in the background I can kind of hear them getting a little bit unruly. But anyway, that's how I tend to do my work. So what did I do? Basic setup. I've gone now to V0.2. Got G25 Shifter working. V0.3 pedals working. To do. Let's get a list of things to do. Extra buttons. G27 pin out, confirm and test. And that's what I need to do. I could potentially auto check. Oh, come up. Derive. Is it 1R? Derive? I think it is. Auto check for data coming from piezo. Pins for G27. This is just an idea for me for later. So what I could do theoretically is look at the loopback pin, and I can check if the loopback pin is either high or low, or even say if I what could I do? I could probably sit there, clock the data in, and if no data's come in off those buttons for a while, it could automatically switch the configuration internal to the library and swap the pins in software, and try and reattach it as a G27. I wonder if I could do that. Can't see why that wouldn't work. Unless, of course, when you plug it in, you press nothing on it and it's just going to be sitting there flipping between the two. Yeah, you don't want that either, do you? What you could do is you could actually put it into, say you put it into 6th gear. No, it's not going to work. I'll work on that. That's another thing. I wonder if I can make the library auto detect the difference and then swap the pins. Swap these pins here on the fly, because I mean all these pins are going to be connected, or at least those 5 anyway. I could theoretically find a way to swap these dynamically based on some condition with reading. You know, if, say for example you put it into 2nd gear, which does work. If you put it into 2nd gear and leave it there and then push some buttons, you could actually have it say, look, if you didn't push any buttons for 20 seconds, if you did that within the first 30 seconds of turning it on, so when the Arduino is first turned on, select 2nd gear, push some buttons. If it doesn't see any buttons pressed, it could flick over the shifter pins, so these data pins, to the other configuration, and if it starts spotting the buttons coming in, save that condition to EEPROM, so the next time we boot it up, it'll say it was in G25 mode or G27 mode. That's got some potential. It's the swapping of the VCC that could be a problem. That's all. They probably did that on purpose just to make sure that you couldn't mix this device with the G25. Why they got rid of the sequential shifter is beyond me. The sequential shifters stood the test of time. I bought my G25 in I don't know 2003, was it 2003 or 4? And it's that shifter's still going 15 years later, at least 15 years later. So I see no reason why the shifter from Logitech through the ages has progressively had less and less functionality. That's just crazy. There's absolutely zero reason why the G29 shifter has got no buttons on it. There's no reason whatsoever that thing needs to be so small and so nerfed. It's ridiculous. Anyway, guys, that's all I'm going to have for you today. I'll compile all this up. I'll make this available. I'll double check the configuration for the G27 shifter as well. And what I'll probably end up doing is I'll make a quick define in here where at the top here you can define G25. You'll change it like a mode, and it'll automatically select the correct definition configuration for your machine. Doesn't really make a big difference. Typically you would actually just wire this as per that, and that would work just fine as well, but that didn't seem to work for me initially. And since I've never ever ran a G27 on this piece of code, I've always ran. That's why this G27 looks brand new. I mean, that leather is just, it's brand new. I think I only pulled it out of the box about a year ago or 2 years ago. I've had it that long, and that's why it looks so new. I've only ever used the G25 and had no reason to. I know the pinout's slightly different, but I left that to most people to figure out what their pinout's going to be. But that's interesting that website doesn't work on this, so I'll have to look at that. Alright guys, for now, thank you very much for tuning in. I think that's been the better part of nearly 2 hours worth of me yakking and mucking about. It's already after midday, and I'll catch up with you guys online. Thanks for tuning in.